So let's say you have this one, dy dx, and then you have this x squared plus 6, and then y minus 7. This is called separable because if you notice, we can have y terms on one end and the x terms on the other end. So if we are going to integrate, we can have 1 y minus 7 dy, because all we did was got this term to that side and divided by 1, and this is equal to the same thing for this one, so this one goes to the other side. So this is the integral of x squared plus 6 dx. So to solve this, essentially we have one term here that we need to solve in terms of y, and the same thing here in terms of x. So let's do that. For these types, this is a typical case of a logarithm, so it's something like this. So on top you need to have the derivative, and at the bottom you have the full expression. So the derivative in terms of y for y minus 7 is 1, and this is what we have here. So the solution for the first one is ln, and then y minus 7. So this is the first one. For the second one, we have x squared, so this is x to the third power divided by 3, so it's 6x plus c. And now, because we have a log here, we can further simplify the expression. We use e to solve for this one, so we get y minus 7 is equal to e 1/3 x to the third power plus 6x plus c. And now we have 1/7 there, can go that way. So now we have just y on this side, so we have e 1/3 x to the third power plus 6x plus c plus 7. And now we can also do an additional operation. The plus c here is a special case because it's like having e to, let's say the whole thing is just x, and then you have a c here. So it's the same thing as saying e x, then e c. And this whole thing is just a constant. So this is a very special case, and what we do here is just get it down. So just c1, and then the rest of the expressions remains the same. And plus 7. This is your final answer. What about this one? So let's say now we have dy dx is equal to x minus 2, and then y squared minus 9. Again, we notice that this is separable because you can get this term with x and you can get this term with y. So let's do that. So for the first term, let's start with y. So when you are doing the integral, you have 1 divided by x squared minus 9 dy. It's equal to, again, same thing for the other side, so x minus 2 dx. So now we can work on both expressions, this one and this one. For this one, we notice that we have y squared minus 9, so we need to separate this into the proper roots. So a is equal to 1, b is equal to 0 because we don't have anything else besides 9. 9 essentially it's y raised to the 0 power, so we're missing the middle term, which is b, so it's a 0. And c is equal to minus 9. So to get the terms, y is equal to minus 0 plus or minus 0 squared minus 4, and then a times b. So in our case it's minus 9. And all of this divided by 2 times a, which is just 2. So our result from this is minus 0 plus or minus 0, and then 4 times 9 is 36, the square root of 36 divided by 2. And here you use the negative 1 for the first one and the positive 1 for the second one. So minus 0 minus 6, so that's minus 6 divided by 2, so that's minus 3. And the second one, so minus 0 plus the square root of 6, so that's positive 6 divided by 2, which is 3. So here, in order to solve these roots, we have, let me change colors, so we have 1 divided by, now we have two things here. We have y minus 3 and y plus 3 dy. Let's continue with this expression. Whenever we have a situation like this, we need to find what's the proper element for this one that we're going to call a, and the second one element for this one that we'll be calling b. So to do that, what we do is 1, which is this one, is equal to a divided by y plus 3 plus b divided by y minus 3. So essentially what we're doing on this side, we are multiplying this whole expression by y plus 3, y minus 3. And when we do that, notice that we have this one at the bottom. So this will be cancelling off with this one, and we're going to be left off with this one there. And the same thing for b. In order to solve this, what we do is just change the terms to the one that gives us 0 on the other term. So let's say we use y is equal to 3. So that cancels a. So we get 1 is equal to 0, plus, since y is equal to 3, plus 3, we have 6b. So b is equal to 1 divided by 6. The same thing for the other one. So if y is equal to minus 3, 1 is equal to minus 3 minus 3, that's minus 6. So minus 6a plus 0. So a is equal to minus 1 divided by 6. So when we rearrange the terms to substitute in the initial expression, what we have is, we have the integral of a divided by y plus 3 dy, then plus b, y minus 3 dy. And since we have the terms now, we know that a is minus 1 divided by 6, so y plus 3 dy, and then plus the other one, which is 1/6, so 1 divided by 6, y minus 3 dy. So we can get this term to the front, so let's do that. So minus 1 divided by 6, so it's 1 y plus 3 dy, and then the other one is the same thing, so plus 1 divided by 6, and then 1 divided by y minus 3 dy. So our expression for this one is the same thing. Notice that we have, like, the derivative of this one is 1, and we have the same case here for this one. So what we do is we get this same expression on top with a log. So this is minus 1/6 ln of y plus 3, and then the same thing for the other guy. So 1 divided by 6, and then ln of y minus 3. And for the x part, our expression was x minus 2 dx. So this is x squared, 1 divided by 2, minus 2x. So this is the part for x. Okay, so let's get both expressions in the same form. So minus 1/6 ln of y plus 3, just getting this thing in the whole expression. So plus 1 divided by 6 ln y minus 3. It's equal to 1.5 x squared plus 2x. You can additionally simplify this a little bit and multiply everything by 6. So you get minus ln of y plus 3 plus ln of y minus 3. 6 divided by 2, that's 3x squared. And then minus 2 times 6, that's minus 12x. And you can even further simplify this a bit, because you have ln here. And as you know, because this is subtraction, this element goes to the bottom. So we are left off with the following. We have ln of y minus 3 divided by y plus 3. So this one and this one. And this is equal to 3x squared minus 12x. Now we can use e to both sides, so we can get rid of this ln. So we get y minus 3, y plus 3, and then we have e, and then 3x squared minus 12x plus c. So now how do we solve this? We have kind of this element that is in a way dependent on this one, but there's a way for us to solve this one. So what we can do is get y minus 3 on one end, and then y plus 3 on the other end. So we have e 3x2 minus 12x plus c, and then times y plus 3. And we can even further simplify this a little bit and take this one element out, because as you notice, this is a constant. So we have y minus 3, and then this is c1 e 3x squared minus 12x, and then multiply it by the other one. So just to simplify the expression a little bit. We can further simplify this expression because we have y on one side and we have y on the other side multiplying by the expression. And the same thing goes for 3. So with 3 is here, it's just a sum subtraction operation, but it's multiplying on this side, so we can use this to our advantage. So we have y minus 3, and then here on this side we have y c1e 3x2 minus 12x. Let me change colors to be easier to see. And then we have the same thing for 3, so we have plus 3, and then it's multiplying by the same expression, so c1 3x squared minus 12x. And now what we can do, this is what I was mentioning before. We have y here, and we can associate this term to this one, and the other one we can do the same. So we can have the 3 part that goes to that other part and associate with that one. Let me show you. So now what we do is we get this whole term to the other side. So this whole part just goes there. So we have y minus y c1e 3x squared minus 12x. And then we do the same thing for the other one. It's equal to 3c1 e 3x squared minus 12x. And now we get 3 to the other side, so plus 3. And because we have the same element here, we're going to associate it so that we can get it out. So what we do is y and then 1, right? Because y times 1, it's y. And then minus c1 e 3x squared minus 12x, right? So what have we done here? So we have y, right? This is this one, and then multiply it by the expression. And here we're going to do the same thing. So it's 3 and then 1 plus c1e 3x squared minus 12x. So now, because we have the same expression on both sides, we can get this whole thing to that other side. Notice that this is not the same expression because this has a minus here and this has a plus. But it helps us because we now can have y as a separate entity. So we have y, and then we have 3 multiplied by the top one. So we didn't change anything. So c1 3x squared minus 12x. So this is on top. And then at the bottom, we have this one that we got that part. So it's 1 minus c1 e 3x squared minus 12x. Right? So all we have done is finding a way of separating y from the other terms so that we can have the expression on its specific form. I want to show you something when they give you initial conditions. So you worked on your ODE and you find the expression and got it in specific form. So in a way that you have only y on one end and the whole thing on the other end. And now they give you what is called initial conditions. So let's say it's something like y0, it's equal to minus 1. So they asked to find essentially the value of c. And they are telling us that y with 0 when x equals 0 is equal to minus 1. So essentially what they're saying is that minus 1 is equal to 3 times 1, which is 3, plus 3. And then when you look at the numbers, essentially it's 0. E raised to 0, that's 1. So essentially we are left off with c1. And at the bottom, it's the same thing. We have 1 minus, and this whole expression, we have x0 there and there. So e raised to the 0, that's 1. So we have c1. So now we need to simplify the expression, rearrange it in a way so that we can find the value of c1. So let's do that. So we get minus 1 multiplied by 1 minus c1 equals to 3 plus 3c1. And this is the same thing as saying minus 1 plus c1 is equal to 3 plus 3c1. So we get the c1 to the other side and this one to the other side. So minus 1 minus 3 is equal to 3c1 minus c1. So minus 1 minus 3, that's minus 4. And then 3c1 minus c1, that's 2c1. So c1, you get this the other way, dividing. So this is c1 is minus 4 divided by 2. So c1 is equal to minus 2.